Instrument name: Hydrostatic Head Tester. Instrument model: M018. Purpose of the instrument: to determine the resistance of fabrics to penetration by water and to measure the pore size of the fabric. Standard test method used: ISO 811, AATCC 127 for resistance to water penetration test, BS 3321 measurement of pore size of fabric. Determination of resistance to water penetration: the hydrostatic pressure test. Purpose: hydrostatic pressure method is used for determining the resistance of fabrics to penetration by water. This method is primarily intended for dense fabrics like ducks, tarpaulins, and tenting. Standard test method conforming ISO 811. SOP: install the required test head and clamping ring in the instrument as per standard test method. Open the water reservoir cover. Make sure that the drain valves 1 and 2 and air out valve are in the closed position. Then fill distilled or deionized water manually in the water reservoir. Check the water level via the viewport so that water level lies between maximum and minimum. Finally, close the water reservoir cover. Connect air compressor with the instrument and switch on. Then open the air compressor supply valve, that is air input supply to the instrument. Set the required air pressure by rotating the air compressor regulator. Open the drain valve 1, keeping both the drain 2 and air out valves closed. Switch on the instrument and press the light button to turn on the lighting of the test vessel. Select Auto Water Refill option in the digital panel to fill up the hydraulic system and test vessel. When the water level reaches to the test surface of test vessel, it will stop filling automatically. After that, select Dynamic Test option. In Dynamic Test, the specimen is subjected to steadily increasing pressure of water on one phase until penetration occurs. The penetration pressure is the pressure at which water first appears at the third place in the specimen. Set pressure gradient as per standard test method. Example: 10 plus or minus 0.5 or 60 plus minus 3 centimeters head of water per minute. Then set maximum pressure to be tested. It is recommended to set the maximum test pressure to the maximum capacity of the instrument, that is 3000 centimeter water column height or a value near to it. Set alarm pressure in the digital panel. The alarm pressure is approximately 80% of estimated penetration pressure. Test time may need several minutes to rise up to the final value. The alarm pressure setting is a function to alert the operator that the current test pressure is close to the estimated penetration pressure. The operator needs to start visual observation of the specimen after the alarm activates. Then press and hold the escape button for 3 seconds to reset. Take required number of test specimens from different places in the fabric so that they represent the material as fully as possible. The fabric may be tested without cutting the specimens. Areas with deep creases or fold marks should not be tested. Condition all specimens as per standard test method. For example, 27 plus or minus 2 degrees centigrade and 65 plus or minus 2% RH. Water surface in the test vessel should be clean and clear. Wipe all the water from the clamping surfaces. Clamp the conditioned specimen in the test head so that the face of the fabric will be in contact with the water. That is, it holds the specimen's face down with suitable tension. Slide it horizontally on the clamping ring over the water surface. Ensure the specimen is in contact with the water without trapping any air under the specimen. Turn the hand wheel in the clamp direction to slightly clamp the specimen. Draw the specimen to remove any wrinkles and then tighten the clamp. The clamping shall be carried out in such a way that water will not be forced through the specimen prior to the start of the test. Press the start button. The run time will start to count and the test pressure will show the current penetration pressure. When the test pressure reaches the alarm pressure, the alarm activates. The operator needs to observe the specimen surface and press the stop button when the water penetrates the specimen at the third place. The penetration pressure and run time will be displayed. Record the pressure as conventional centimeters of water at which water first appears at the third place in the specimen. Do not take into account very fine droplets which do not grow after being formed. Do not count subsequent drops which penetrate through the same place in the fabric. Note whether the penetration of water at third place occurs at the edge of the clamp. Reject any test in which such penetration occurs at a pressure less than the lowest pressure recorded for the other specimens from the same sample. After recording the test result, press and hold the escape button for 3 seconds. The result will be reset and the pressure in test vessel will be released. After that, unclamp the specimen and wipe all water from the clamping surfaces. Repeat the test for other specimens. Measurement of equivalent pore size of fabric. Bubble pressure test. Purpose: to measure the equivalent pore radius, which provides an estimate of the size of the interstices in all types of fabric which are permeable to air. The method is particularly applicable to water repellent and filter fabrics. Standard test method conforming to BS 3321. SOP. The pore size attachment should be connected to the air-out connection situated on the rear of the instrument with the tube supplied and valve opened. Connect air compressor with the instrument and switch on. Then open the air compressor supply valve, that is, air input supply to the instrument. Set required air pressure by rotating the air compressor regulator. Then switch on the instrument and open air out valve to supply the air from instrument to the pore size attachment. Next, select the pore size test option in the digital panel of the instrument. Then set the pressure gradient as per standard test method. Example, 200 to 250 mm head of water per minute, that is 2 to 2.5 kPa per minute. Set the required maximum pressure. Example, 10 to 100 cm water column height. Check or determine the surface tension in the white spirit or equivalent liquid bottle. Set the surface tension value 20 to 30 millinewton per meter of white spirit or equivalent liquid in the digital panel. The surface tension of white spirit usually lies between 24 to 27 millinewton per meter, with a temperature coefficient of minus 0.005 millinewton per meter degrees centigrade at standard atmospheric conditions. Take 10 test specimens, each of size 50 mm diameter, from different places in the fabric, so that they represent the material as fully as possible. Areas with deep creases or fold marks should not be tested. Condition all specimens as per standard test method at 27 ± 2 degrees centigrade and 65 ± 2% RH for at least 24 hours. Soak the conditioned specimen under about 15 mm depth of white spirit or equivalent liquid in a glass dish. After soaking for a minimum period of 3 minutes, remove the specimen. Clamp it on the testing head of pore size attachment. Pour a few milliliters of white spirit or equivalent liquid onto the surface of the fabric, just sufficient to cover the fabric completely after it has bulged slightly under the pressure exerted on the underside during the test. Press the start button on the control panel. The pressure required to force air bubbles through the interstices of fabric wetted by a liquid and having a film of the same liquid applied to its upper surface is observed. This pressure, together with the known surface tension of the liquid, is used to estimate the size of the interstices in the fabric. Under increasing air pressure, bubbles appear at different places over the upper surface. Observe the specimen continuously while the pressure is increasing. Record to the nearest millimeter the pressure at which the first bubble appears at the third place on the upper surface of the specimen. Press the stop button to terminate the test. The result will be automatically displayed in the digital panel of the instrument. Then calculate the equivalent pore radius in microns to the nearest micron for the specimen using the equation R is equal to 2T into 10⁶ by rho Pg. Or simplified, R is equal to 204 T by P, where T is the surface tension of the white spirit at the temperature of the test. See standard test method or label on bottle of white spirit. G is the acceleration due to gravity. Rho is the density of water at the temperature of the test. P is the bubble pressure expressed in millimeter head of water. In this case, we can approximately take rho is equal to 1 mg per cubic millimeter and G is equal to 9810 millimeter per second square. Next, unclamp the tested specimen and wipe all liquid from the clamping surfaces. Repeat the test for other specimens.